This video will focus on finding the solution of systems of linear equations in three variables. We have this linear equation here with variables r, s, and t. So the first thing we do is to identify our equations and name them. So say this is our equation 1, equation 2, and then equation 3. What we're going to do next is to pair two equations and eliminate one of the variables. Say, for example, I will combine equation 1 and equation 2 to eliminate r. Okay, I want to eliminate r. To eliminate r, I need to make their coefficients the same and then with opposite signs. So what we're going to do here is I will multiply this by negative 3 so that this will become positive 6, and if we add the two equations together, r will be eliminated. So it's going to be negative 3 times the equation 2. So this is what will happen to equation 2. We have 6r minus 6s then plus 9t equals negative 15. And next, for the equation 1, we just simply copy it. That's minus 6r minus 5s plus 2t equals negative 18. Then we add these two equations together. Our r is eliminated, and this is equal to negative 11s plus 11t equals negative 33. Okay, so we'll let this as our equation number 4. Next, we need to pair another equations and eliminate the r again. Should eliminate the same variable so that we'll reduce the system into two variables. We cannot pair the same equation, so we need to pair different ones. Say, for example, equation number 2 and number 3, or you can have equation number 1 and number 3. So let's pick equation number 1 and 3 because it's easier to eliminate the r. Now what we're going to do here is we'll multiply this by 2, so that we multiply 2 to 3r, that's 6r, and its opposite sign with the first equation, and r will be eliminated. So we'll be using equation 1 and equation 3 to eliminate r. Alright, let's now multiply r2 to equation 3. That gives us 6r minus 2 times negative 4, that's 8s. 2 times negative t, that's negative 2t. And then 2 times negative 4, that's negative 8. And then we'll copy our equation 1. That's negative 6r minus 5s plus 2t equals negative 18. Here, we'll add them. This is equal to 0. R is eliminated. And this is negative 13s. And this t is also eliminated here. So we have negative 8 minus 18. That gives us negative 26. We divide negative 13 both sides. That gives us s equals 2. We have the value of our s already, and we can use this to equation 4 to solve for our t. We substitute s equals to 2 to equation number 4. So we're gonna have negative 11, change the s to 2, plus 11t equals negative 33. 3. Now this is equal to negative 22 plus 11t plus negative 33. You can move this to this side, becomes plus 22. Okay, it's now 11t equals, this is equal to negative 11. Divide 11 both sides. And this gives us t equals negative 1. Alright, we're now left with only one variable, which is r. We can solve our r using any of the equation 1, 2, or 3. So I will choose equation 1 and substitute my s equals 2 and t equals negative 1 to equation 1. Okay, we now have negative 6 times our r. We don't have our r. This is the one we need to solve. Minus 5 times s is 2. Then plus 2 times our t is negative 1 equals negative 18. And then let's continue. Negative 6r. This is negative 10 minus 2 equals negative 18. Negative 6r. This is negative 12 plus negative 18. We can transpose this to this side. It gives us plus 12. So let's continue here. We have negative 6r equals, okay, it's gone already, equals negative 6. And then we divide negative 6 both sides. That makes r equals 1. Okay, now if you want to check your answer here, you can make a quick substitution or checking here. So our r is 1, that gives us negative 6 here. Our s is 2, gives us negative 10. Our t is negative 1, gives us negative 2. We add them together, negative 6, negative 10, negative 2, it gives us negative 18. So this is correct for the first equation. Let's go to the next equation. We have to test it to the 3 equations. Okay, r is 1, so this is negative 2. S is 2, this is positive 4. If t is negative 1, this is plus 3. And we put this together, this is 7 minus 2, that gives us 5. So it's correct. And this one, 3 times our r is 1, this is 3. Then 4 times s is 2, this is negative 8. Then t is negative 1, that's plus 1. And put this together, it gives us negative 4. And the values of our r, s, and t satisfies all equations. So therefore, the solution set, we are very confident that our r is 1, the s is 2, and then the t is negative 1. Let's try this second system. Let's name this as our equation 1, equation 2, and equation 3. Let's eliminate one variable. Let's eliminate y. Okay, eliminate y. And we'll be using equation 1 and 2. Easier to eliminate them. So we have equation 1 plus 4x plus 4y plus z. Just copy it. And then the equation 2, just copy it again. Then we add equation 1, equation 2, that gives us 6x, y is eliminated, plus 2z equals 24. Let's take this as our equation number 4. Next, we eliminate y again. So we need to eliminate the same variable so that we can reduce the system into system of two equations with two variables of the same variables. Now, we already paired 1 and 2, so we need to pair another 2. Make sure it's not the same as the first we paired. So we could pair 2 and 3, but it's easier to pair 1 and 3 because y can easily be eliminated for that pairs. So we have now copy equation 1. And then we copy equation 3. That's 5x. Then we add them. That is now 9x. Y is eliminated. Our z is now 4z equals 36. Let's take this as our equation number 5. Now notice equation number 4 and equation number 5 are equation of two unknowns of the same unknowns. So we can now eliminate one of the variables here. Okay, I will write my equation 4 and 5 here again. Put them together. You have 6x plus 2z plus 24. And then equation number 5, that's 9x minus 4z plus 36. It's easier to eliminate the z here, so if you multiply this by 2, so we have now 12x plus 4z equals 48. And then we copy this question number 5. It's 9x 36. Now here our z is eliminated. Now we add the coefficients of our x. That's 21x. This is equal to 84. Now we divide 21 both sides. That gives us x equals 4. Okay, now we already know the value of our x, and we can plug it in, or we can substitute it to equation number 4, equation number 5 to solve our z. Now I will select equation number 4. Let's change our x to 4 in equation number 4. Okay, plus 2z equals 24. And this is 24 here, plus 2z plus 24. Move our 24 to this side, that's minus 24. Go on here, we have 2z equals 0. That means our z equals 0. So we now have the values of our two variables. Next, we only need to solve. We have the x already, we have the z, so we're left to solve for the y. Now we can select, we can choose any of these equations here. It could be equation 1, 2, 3. I will select equation 1 instead. I'll substitute x equals to 4 and z equals to 0 to equation 1. Okay, to equation 1. We have now 4, or x is 4 plus 4y plus our z is 0 plus 24. And this is 16 plus 4y plus 24. Let's move our 16 here. It's going to be minus 16. It's gone. So that's 4y. This is equal to 8. and we divide 4 both sides. That gives us y equals 2. Okay, therefore, the solution set, you can check if these uh, values where x, y, and z are really true to give us the solution set. So we assume that they're true without checking, or x equals 4, y is 2, and then z is 0. Or else you can make a quick substitution here. If you really want to check your answer, so when our x is 4, so this is 16 here. Y is 2, so this is 8 here. Z is 0. So that 16 plus 8 gives you 24. That's correct? Okay. Here, when your x is 4, gives you 8. And y is 2, it gives you minus 8. Z is 0, 0. So 8 minus 8 is 0. Plus 0, 0. Okay, here, when our x is 4, it gives us 20. X is 2, that gives us 8. Z is 0, this is 0. So we add this, that's equal to 12. So all in all, it's correct. Let's move to the third system, this one. Now, to look at this system, it's not yet arranged, so we can arrange this to solve it properly. This one, x minus 3y plus 3z equals 8. Here we have, okay, I'll move my 4x here, gonna be minus 4x, 5y to the other side, so minus 5y plus z. Z will stay there, and the negative 4 will stay on its place, negative 14. All right, there. Next here, let's arrange this. That's 3y, it's already arranged, plus 2z equals 14. Now, let's name this as our equation number, okay, wait. Equation 1, equation 2, and equation 3. Our equation 3 is already 2 variables, so we can do anything here. Now, if we go to 1 and 2, if we eliminate the x, we'll reduce to 2 variables, y and z, and then we can pair it to equation 3. That's our plan. So we'll pair this, equation 1 and 2. So we have, so what we're going to do here, we eliminate the x. That means we're going to multiply this by 4. Okay, so that our x will be eliminated. So 4 times x for equation 1, this is 4 times equation 1. So 4 times x, that's 4x. 4 times negative 3, that's 12y. 4 times 3, that's 12z. 4 times 8, that's 32. And then for equation number 2, this equation number 2 here. All right, that's minus 4x minus 5y plus z equals negative 14. Okay, x is eliminated, so we have negative 17y, and this is equal to 13z. And then our constant is now, what is this, 18? Okay, 18. Okay, that's 18. Now let's take this our equation number 4. So we put the two equations together, the equation 3 and equation 4, because they're now reduced into 2 variables, y and z. Equation 3 is 3y plus 2z equals 14. Equation 4 is negative 17y plus 13z equals 18. We can eliminate one of the variables here. Let's select the y. Okay, so multiply this by 17. This one multiply by 3. So 3 times 17, that is 51. Y. 17 times 2, that is 34. Z. 17 times 14, multiply it. 17 times 14, that is 28. Carry 2, 4, 6, 7, and 1. So that's 8, 3, 1, 238. That's 238. Let's multiply this one. That's negative 51y. And this is plus 39z equals, okay, that is 30, that's 54. Okay, cancel this out. Let's add this together. That is 3, carry 1 there. That's 7, 73z. Let's add this. That's okay, that's 2, carry 1, 8, 9, 2. That's 292. And divide 73, both sides. 73. Cancel out. So z is equal to, is equal to 4. Alright, now we can substitute our z equals to 4 to any equation number 4 or equation number 3. Let's try equation number, we can try any of this. I'll try equation number 3. So substitute z equals to 4 to equation 3. Okay, we have now 3 times y plus, change our z to 4, plus 14. And then let's continue here. We have 3y plus 8 equals 14. Move our 8 here, it's minus 8. It will be gone. So 3y. Now 14 minus 8 is 6. Divide 3 both sides. Y equals 2. So therefore, oh, not yet. So we have solved 2 variables. We're still left with the remaining variable, which is x. So easier to use this equation here. So we'll substitute our y equals 2 and z equals to 4 to equation 1. Okay, so we have x equals 3 times change our y to 2 minus 3 times change our z to 4 plus 8. So this is now x equals 6 minus 12 plus 8. So x equals, this is negative 6, x equals 2. Okay. So therefore, our solution set is equal to the point where x is 2, y is 2, and then z is 4. Okay, next let's do this equation. We'll do the same. We arrange the equation first. We have here, now we'll arrange it this way, minus x plus y minus 4z equals negative 5. This equation 4x plus 3y minus 2z equals 5. And then the third equation, that is 2x. We don't have y, so plus z equals 2. And this is our number equation number 1, equation number 2, equation number 3. Now, our equation number 3 has two variables only, so we need to deal using 1 and 2, remove variable y in 1 and 2 so that it will be reduced to two variables x, z. Okay, so now we'll write negative 1 and 2. Okay, so we'll write down the equation 1 first. That's x plus y minus 4z minus 5. And equation 2, 4x plus 3y minus 2z plus 5. We're going to eliminate the y, so that will be reduced to equation with two variables x and z. I'll multiply this by negative 3. Okay, so this is now 3x minus 3y plus 12z equals 15. Then this is 4x plus 3y minus 2z equals 5. Okay, so y is now eliminated. I will continue it here. I have 7x, that's plus 10z equals 20. This is our equation number 4. Okay, and then we're going to put our equation 3 and 4 together. So we have now 2x plus z plus 2, and then 7x plus 10z equals 20. Okay, let's eliminate z because it's easier. If we multiply this by negative 10, we have now negative 20x minus 10z equals negative 20. This one is 7x, 10z plus 20. So z is eliminated. We have now negative 13x equals 0. We divide negative 13 both sides. So x is equal to 0. And then we already have value for x. We can substitute it to our equation 3 or 4. Yeah, we'll use equation 3 instead. Substitute my x equal to 0 to it. This is from equation 3. So 2 times 0 plus z equals 2. And this is 0. So z equals 2. Okay, we got two variables solved already. We're left with variable y. I will use this equation instead. So now solve it. Okay, substitute x equals 0, z equals 2 to equation number 1. This is equation number 1. They're the same here. So equation number 1, equation 1. We have now y equals, our x is 0, our z is, where's our z? Z is 2 minus 5. So this is now 8 minus 5 gives us y equals 3. Alright, you want to check this possible solution, and we can plug it into our original equation here. So when your y is 3 equals x is 0 plus 4 times 2 minus 5. So this is equal to 8. So that's 8 minus 5. That's equal to 3. So this is true. And the second equation, 4 times x is 0. 3 times y is 3. Minus 2, z is 2. Plus 5. Let's continue solving it. This is 0. That's 9 minus 4. That gives us 5. Okay, it's true. That's equal to 5 there. So z is 2. Z is 2 equals negative 2 times x is 0 plus 2. Okay, that means 2 equals 2 because that's 0 there. That's true. Therefore, our solution set is equal to the set containing the point where x is 0, y is 3, and then z is 2. Now, if you want to solve more problems, okay, I have these two system of equations here. You can try it yourself.